Welcome back, honors. So as we talked about in the previous video, I skipped this problem. I just want to go back with y'all and kind of clarify this. So this right here, when I have this angle on the outside, that was what classified this problem as an outsider. And the rule for outsiders is to subtract the arcs and divide by 2. And that's where you have a problem here, because I have this arc as x, but I don't have this other arc. So if I go to subtract the arcs and divide by 2, the problem is that I'm missing things. I would end up with 2 variables. But this is a special case because we know that all the arcs in a circle, or all the way around, is going to add up to 360. So if this piece is x, I could call this piece 360 minus x. And that's the clue in solving this problem. The full circle should add up to 360, right? And so if we knew this number was 20, then I would do 360 minus 20, and that would tell me this piece was 340. If I knew this part was 300, I would do 360 minus 300, and that would tell me this other piece right there. So in this case, I don't know, it's x, but I do know that the other piece would be 360 take away x, whatever that is. And now I'm going to follow my outsider rule of subtracting the arcs, dividing by 2, and that's going to equal my outside angle 45. So I'm going to subtract the arcs, so 360 minus x divided by 2 equals our outsider 45. And then from there, I can kind of clean this up, combine like terms. So the minus x would just become minus 2x. And then you could set up a proportion cross multiply. If you see that fraction, I could also just multiply both sides by 2. So now I have 360 minus 2x equals 45 times 2 is 90. I'm going to move the 360 over to the other side, subtracting that out. So now I have negative 2x equals negative 270. Divide both sides by negative 2, and remember that 2 negatives will give us positive 135 degrees. And that's it. So then let's take a look at this last one down here where I don't really have any numbers, but I do know that the observer watches people riding a Ferris wheel, and the Ferris wheel has 12 equally spaced cars. And that's your clue right there. Because if all these cars are equally spaced, I can find this. Because if I catch it, x is an outsider, that angle is an outsider. And remember that your rule for finding an outsider is to subtract the arcs and divide by 2. And if there's 12 equally spaced cars, then I can find out what each piece is. So 360 divided by 12 is 30. Which means that this arc over here, that's 1, 2, 3, even though it's 4 cars, but they're equally spaced, so like 1, 2, 3, that would be 30 degrees. And then this other arc over here, I'm just going to go and count, so that's 1, 2, 3, 4, 5. 5 times 30 would be 150, because remember, each car is 30 degrees. I know that because there's 12 cars. 360 divided by 12 means each one has 30 degrees between it. And then from there, I'm just going to subtract. This shouldn't be 30. That should be 90. My bad. 3 of them at 30 would be 90. And then from there, I'm just going to subtract the arcs and split it in half. So 150 for our outsider would be 150 minus 90 split in 2. And this 150 was from 5 times 30 because there were 5 increments between. There were 3 increments, 3 times 30, and I got 30 from 360 divided by 12. So 150 minus 90 is 60. 60 divided by 2 means that the observer is watching at an angle of 30 degrees. So hopefully that clarified some of those challenging problems that were on here that I skipped over in the last video. But now I want to take a look at your assignment and your practice because there's some challenging problems on there. And I want to start with number 8. Number 8 says that both circles are centered at O. And whenever you have 2 circles like this is an example of concentric circles. Concentric circle is just concentric circles or just circles that have the same center. So these are concentric circles. They have the same center. Okay, I know that EF is 70, the arc. So EF is 70. And I know that AC is 16. Find BD. Now, I have two circles here, and I have different angles and arcs in the circles. Because if I look at the big circle and I ignore that little one, that's a crisscross right there. And if that crisscross, if I can solve that crisscross, remember, crisscross would be add the arcs, divide by 2. If I knew what this one was, then I could add and work backwards to go from there and find this other arc. But I don't know what that angle is. But if you catch it, this angle that would help me solve the crisscross is an inscribed angle in the smaller circle. And I know that this is a diameter, right? So that's a semicircle that adds up to 180. And I know that this piece is 70. So if that's 180, subtract 70. That would make this piece 110, which would make this angle going in for an inscribed angle I divide by 2. That would make this angle 55 degrees. So I started with the inside and worked my way out because now I have this problem. I have a crisscross. And I know that this is 16 degrees. I know that this is 55 degrees, and I'm trying to find that right there. Trying to find that arc. And kind of the clue with that one is to look at the smaller circle with the inscribed angle and then work your way backwards. So hopefully that kind of helps on this one. B is just really similar to the other challenging problem that I just showed you on the notes. And then just to make sure that you're on the right path, on number 14, I'm going to go ahead and give you the answers to those. Not so you can just copy these down, but so you can actually kind of check these and make sure that you're on the right path. So it should be 16 degrees, 14 degrees, 52 degrees, and 84 degrees. So hopefully that gives you a little bit of help on some of those more difficult problems so you can at least check it as you go. And if you can do these challenging ones, then you are in great shape for your quiz. There's not going to be any super difficult ones on the quiz. It's more just checking, did you watch the videos? Do you have knowledge of crisscross, insiders, outsiders, wannabes? Do you actually know what you're doing on all of these? Okay, best of luck.